Hey folks, in this day and age, hopefully if you're writing .NET apps, they run cross-platform. But when we deploy our apps to device form factors like mobile or desktop, we want to leverage those plethora of device sensors and APIs. Thankfully, we don't need to write platform-specific code for any of it, and AI can really help. So let's dive in and take a look. My chosen stack for building cross-platform .NET apps these days is obviously Una platform. It's open source, it's fast, and keeps me productive with lots of design and AI tooling. The good thing is you can use as much or as little of the platform as you want. You can do this from any OS. You can bring your tools, any IDE, and any AI agent of your choice. But at the core of it, you are building a single code base, a single shared project with XAML and C#. And from that, my app just runs everywhere. I got iOS or Android for mobile. I got web browsers. I got Windows, Mac OS, and Linux for desktop and embedded systems. But once I'm building this cross-platform app, I want to leverage those APIs. So how do I get to that? Well, the obvious place to start is our docs, right? So I can read up on all of this. And in fact, if I go down to references and if I look at all of the non-UI references, that's what we are talking about, right? So if I look at the overview, all of this starts from some of the WinRT namespaces, but they're meant to be cross-platform. So I don't need to write Java or Objective-C or Swift to get to any of those platform APIs. I can just do this all from C# and .NET, and it simply works everywhere. And there is a lot in here, right? Dozens and dozens of APIs. So for example, anything that I want to take, let's say battery information, I want to know what's the user's battery information like, how much life is left, and so on. Now, oftentimes we will say there are platform-specific requirements, like for Android, do this, for iOS or WebAssembly, do that. But otherwise, it's very simple C# code that we are writing. Another one that's very common is camera capture, right? So we want to deploy our apps to a device, and we want to let the user take a picture or pull up a picture from their media library. So again, there are platform-specific permissions on different platforms. Like Android has this, and iOS has it. And then the code that you write is just flat out C#, right? So let's take a look at some of this in action and see if AI can actually help. So I'm going to pull up a simple code editor here. That's Visual Studio Code for me. And I have a very simple app here that is meant for me to read device APIs, right? It's cross-platform by nature. It's just file, new project, platform app, and it just runs everywhere. Again, if you're new and getting started, we do recommend that if you look at any of the getting started guides, there's a lot in setup. So bring your tools however you want to start. But let's just say you're on Windows and you are using Visual Studio. Get the templates and get the extensions, and then for no matter which platform you're on, run this tool called UnoCheck. It's one command line tool that gets you all the bits, the cross-platform SDKs that we depend on, the simulators, so you can build and actually deploy your app, right? So run those UnoChecks, setup tools, get the IDEs of your choice, and get started. So I already have all of my tools lined up, and this is a super simple Uno platform app. So what you see here in the CS proj is nothing different. I don't have any NuGet package dependencies. All of this is actually just built in out of the gate. I do have some target frameworks, so I am running this on .NET 10 runtime and iOS or Android, Wasm, desktop, you name it. No particular SDK features is it that I'm using, but you can see from my global JSON, which is a simple file that we drop in your project, this controls which version of Uno SDK are you using. This obviously has impact on the iOS or Android or Windows or Mac OS versions and the runtimes that kind of go along with it, right? So choose one, and UnoCheck is going to get all the runtime bits lined up for you. So once I am ready to start building, this is my main page.xaml, my first view, and I just want to see some device APIs, right? Without going into Objective-C or Swift or Java or C++ stuff. I just want to write .NET, modern .NET, and be able to leverage those APIs. So I have a few simple text blocks here. I want to see how much is the battery. I want to see some location information. I want to see what network the person is on, my user is on, and I want to be able to take a picture, show some things in my media library, and so on. So how does any of this work? Well, first up, you have to choose one platform at a time to make sure the permissions are right. So for example, I am running this on Net 10 iOS, and I'm going to deploy this on an iPhone 17 simulator. So if I go into my iOS settings, this is where you do have a single project, but you have a platform specific folder. So your platform specific things do go in there. So your Android manifest files, they go in there. For iOS, my info plist and some of the references as to how your app bootstraps and starts up. Those are the few platform specific things that go in that folder. So if I look at my info plist file, I do have a couple of extra permissions here. So first up, I might be reading the user's geolocation. So I'm going to say NS location. So that's, again, an iOS specific setting. Do not say that you're going to stalk the user. I might leverage the camera. Again, do not say that you don't care about privacy. Obviously, these things are important. I'm just showing you an example here. So make sure you have those permissions set for iOS or Android, Windows, wherever you're doing this. So with that, I have a few text blocks. I just want to read some stuff. So when my app loads up, first up, I want to make sure that, as this page comes along, I want to be able to have all of the APIs. So I have a few using statements up here. If Android or iOS, I have some more, specific media capture namespaces, but they're all the same between iOS, Android, Windows. So I want to read, the battery status, and I want to read, your network status, right? So are you on Wi-Fi or 3G, 4G, 5G, 6G, you name it. So let's actually go ahead and run this app. And I will run this on iOS, which is what it's selected. And it's going to do a build for Net 10 iOS and bring it up on a simulator. Still doing a build. So it'll get all the NuGet packages, everything else that's needed. And up comes an iOS simulator, and it's going to deploy. And see, it's telling me this is an iOS syntax, right? So it's saying, hey, this app is wanting to read your location. Is that okay? As a user, you will just set it once. So let's just set it once here. Now, what you do see here is a couple of things already out of the gate, because I did it on the navigation event as the page loads up. So it's saying, hey, battery status not present, because this is a simulator. It doesn't actually have a battery. If you did deploy this to an actual phone, you will get the actual battery status. Now, the device geolocation. All of that code is just .NET code, right? So device geolocation comes down to this method here. So I'm reading the geolocator, and I'm requesting, asynchronously your geolocation, right? So if I get into errors, I will say that I cannot read your location, or please enable location access. But if I am able to read your geolocation, then I'm going to report the latitude and the longitude of where my user is. And that's exactly what you see here. This being a simulator, this is probably Apple's, Cupertino headquarters, the geolocation lat log. So that's what you get. Same with network access. Again, I can read what is the level of network access that you have, and report it right up here. Again, given it's a simulator, it just says I have network access. So those things work really nicely. Now, if I were to go a little bit more, camera access, right? Very, very common. So if I go into, taking a picture, out comes the classic iPhone or Android picture taking app, and it's going to say, hey, here's your way to pull up a picture. And once I do take a picture, it's going to give me a file back. Again, this being a simulator doesn't actually have a camera, right? And all of this is very, very simple code. So take a look at what my capture photo async is. So essentially, here is the take a picture button. And when I click on it, I'm firing up a click event handler. And I am pulling up the camera, the capture photo async in here, and I'm simply saying capture file async. It's going to pull up the camera app, and it's going to give me a file back once the user does take a picture. So all of this is great, and I can go back to the docs at any time, and I can look up my reference of dozens and dozens of non-UI APIs that I can do. So your contacts, your clipboard, your email and file pickers and geolocation, gyrometer, accelerometer, you name it. Pretty much everything that you can think of on the devices, you are well covered. But it does actually mean that you have to go to the docs and over look it up. Like, how do I do camera? How do I do battery? How do I do geolocation or accelerometer? You sure can, but it's time consuming, right? And this is where AI comes in and really helps. Because the other thing we have, let's go back into our docs here, and let's look at MCPs. These are model context protocols. And this is meant for people who are wanting to use AI agentic workflows or AI models in their development workflows. And we don't want AI to be going blind. You want them to have contextual expertise. So these are a couple of MCP servers in here. The first one here is the most important one in this case. This is just an UNO MCP. And what it's telling you or telling the agent is, hey, these are some tools that are at your disposal. I can do a doc search. I can do a doc fetch. So no longer does the AI agent need to depend on the models, could be dated knowledge. It can actually see those tools and fire off calls, so it can do a documentation search for you and generate some code that's powered and grounded by the very latest docs. And then we of course have app MCP, which is more of the interactivity bits. You can actually have AI not just generate code, but actually test the UI is verified and working. So this can actually start up your app, close down your app. It can click on things, it can type in text. So a lot of interactivity while your app is running. So no matter what AI you are using, you want to make sure that your AI agents have access to these MCP tools. So I already have that. So here's my VS Code, and if I bring up my AI chat window, this is Copilot, and it's using Codex 5.3 in this case. If I click on the configuration, you will notice that I have these two things, UNO and UNO app. So this is the UNO MCP tools, which lets me search docs, fetch docs, initializes the agent correctly. And then I have UNO app MCP, which is half a dozen tools for me to interact with my app while it's running. So again, no matter where you are at, whichever AI agent you're using, be it in your IDE or be it in your terminal, so things like Claude Code or GitHub Copilot CLI or Codex, any of those internal things, there are ways to just add MCP tools to them. So no matter what AI agent you're using, you should be able to use those MCP tools. And once you have those MCP tools, especially the doc search and fetch, you don't need to go back to the docs. You can just stay in your IDE or stay in your terminal all day. So I had this app where I had written up just a couple of things about the battery and the geolocation, but I didn't have the photo capture thing. And a friend of mine was asking, so I was like, I should just ask AI. So I start out saying, hey, do you have access to MCP tools? And it says, yes, I do. And it says I can do doc search and fetch. And then I say, hey, can you wire up the click event handler so I can take a picture asynchronously? And then I say, hey, how about once I do take a picture, I want you to display the file, the image that the user selected in the media library or from the media library into the app itself. So it did all of that. So here is my show media library. And when I click on that, it's pulling up kind of a default simulator, in this case, iOS 1. It's saying, here are the default pictures. Again, if you ran this on a real device, it's going to pull up the media library that the user has. And I can select an image in here, and it brings it right back, right? So all of this is code that AI is generating. It's going through the file generator logic, the media picker logic that is recommended by our docs, and doing all of this by itself. So what AI in this case added was, here's a quick show media button, and I have an actual image. And once you do select an image from that media picker, here's the media picker async call. So we are loading up the picture library, and we are filtering the file types to let you choose images. Once you do select one, I'm going to grab the source of that image, and I'm going to draw the exact file stream out of that image, and I'm going to show it to you in that source. The image UI container that I have, I'm just going to point it to the file's source and file stream, so I can see the image showing up in my simulator. So what I'm trying to say here is, any type of device API or sensor that you want to access from an UNO platform, cross-platform app, you can do it purely with C# and .NET. And you don't need to write any platform-specific code. Just about everything that you can think of is already covered. And if you go look at the docs, we have lots and lots of samples as well. So take a look at some of those samples. Pretty much anything that you are thinking of doing, it probably has already been done and covered. So take a look at the docs. And if you don't want to look at the docs, then stay in your IDE, stay in your terminal. Just make sure you have the MCP tools, and it's going to go and pull up the docs. It's going to do a search, bring back the exact documentation that you need to be able to wire up these APIs and build up your UI that is truly cross-platform and leverage device APIs and sensors truly in a cross-platform abstraction way. So what you're writing is pure C# and .NET, right? That's it. So if you are looking for cross-platform apps that just simply run everywhere, start with Uno platform, look at the docs, use AI, but at the end of it, this single source and the single project, single code base is what you're looking for, and all of your device API apps, they're all abstracted and they are working purely from .NET. So one source code base that gets you running on device sensors and APIs being leveraged on every platform that you are, deploying your app to. So what's not to like as a .NET developer, right? So solid docs, complete coverage over device APIs, and lots of AI to help you out be productive. So go use any of these device sensors, light up beautiful user experiences for your users, and go build the next amazing thing. We can't wait to see what you build. And thanks a lot for watching. I hope you have fun, and thanks for watching. Bye.